Greetings everyone, this is Kartikeya S bearing USN 1VE19ME017 from Sri Venkateshwara College of Engineering, Bengaluru. I am going to give a presentation on my internship experience which is carried out at Dynamatic Oldland Aerospace under the internal guidance of Mr. Giriswamy VG, Assistant Professor, Department of Mechanical Engineering, Sri Venkateshwara College of Engineering, Bengaluru. Dynamatic Oldland Aerospace is a subdivision of Dynamatic Technologies Private Limited, JKM Plaza, Karnataka Industrial Area Development Board, Devanahalli. I have carried out my internship on Methods Engineering under the external guidance of Mr. Narasimhamurthy, Team Leader of Methods Department. My internship includes about the company, objectives, plan of work at company, tasks performed, methodology, manufacturing sequence, conclusions and references. Before going to the presentation, let me speak a few words about methods engineering. Methods engineering plays a crucial role in aerospace industry by optimizing the manufacturing and production processes, which is involved in the development of aircraft and aircraft related components. Some key roles which is to be kept in mind while contributing to the methods engineering. Those are process optimization, standardization and documentation, lean manufacturing and continuous improvement, production planning and scheduling, ergonomics and safety, automation and robotics integration, quality control and inspection. Methods engineering basically in an aerospace industry mainly focuses on optimizing the manufacturing processes, improving efficiency, ensuring safety and quality, and also integrating automation technologies. So these efforts contribute to the overall competitiveness, reliability and success of aerospace companies in designing and manufacturing aircraft and related components. About the company, Dynamatic Technologies Private Limited designs and builds highly engineering products for hydraulics, automotives and methodology, aerospace components, etc. So under hydraulic segments, components like valve, fan base, gears and pumps are manufactured. Under automotives and methodology segment, components like engine, transmission, turbochargers are manufactured. And also Dynamatic Technologies Private Limited acts as a supplier for Audi, BMW, Nissan. Under aerospace segments, there are three projects: Airbus A330 project, Bell 407 project, Boeing Chinook project. Under aerospace segments, components like wing flaps, fuselage, ailerons, wings are manufactured. The facilities located in India are Bangalore, Chennai, Coimbatore, Nasik. In United Kingdom, Swindon, Bristol, and in Germany, Schwarzenberg. Dynamatic Technologies upholds three design laboratories in India and Europe. Dynamatic Technologies is a leading private R&D organization with numerous inventions and patents to its credit. The company and its subsidiaries employ around 50 scientists, 500 engineers with expertise in mechanical engineering, advanced computer-aided engineering, material and metallurgical engineering, fluid dynamics and defense, and aerospace research. Outlook over the company interior. This is the first picture represents that Mr. Udyant Malhotra, CEO Dynamatic Technologies Private Limited, Dr. Raja Ramanna, who is overviewing the process and sub-assemblies of aircraft components at Dynamatic Technologies Private Limited in 1992, and also in 1998 and Dynamatic Technologies has bagged Creative Partner Award, which was awarded by DRDO, ADE and ASIEO. This is the first picture which represents actual table works and jig works which will be carried out daily inside the company. And this is the sub-assembly of helicopter. This is Boeing Chinook project. And the next two pictures represent how laymen will be working on the particular projects. Coming to the objectives: to explore career alternatives prior to graduation, to integrate theory and practice, develop work habits and attitudes necessary for job success, develop communication, interpersonal and other critical skills in the job interview process, build a record of work experience. Let me speak few words about aerospace standards. AS 9100 means Aerospace Standards 9100 represents first international effort to formulate a quality management system standard for the aerospace industry, which includes design, manufacturing, maintenance, and distributing companies. The standard supplements ISO 9001, which addresses the additional expectations of the aerospace industry. So there are several categories under AS 9100. Among those categories, ISO 9001, which is related to aerospace industry, is one. AS 9100 has already got three revisions: Revision A, Revision B, Revision C. The latest one was released in 2009, which is called as Revision C, in order to align with the standard ISO 9001-2008. It was first published in the year 1999 and was replaced by AS 9100. Dynametrics Woodland Aerospace is been working on latest revision, that is Revision D, which was released in the year 2016. Actual plan of work in a company. The first work process is all process overview. The second one is preparation of AOS, that is assembly operation sheet for helicopter assembly. Third one is calibration of helicopter sub-assembly part. Fourth one is instrument handling, riveting process, heat treatment process, sheet metal operations, CMM operations, reviewing all methods engineering documents. All process overview in the sense there are many processes which will be carried out on particular project. It may be of drilling process, riveting process, adhesive application process, painting process, etc. Preparation of AOS, assembly operation sheet or root code or data sheet, which contains in detail about the type of material to be used, type of tool which is to be used, and type of rivet if applicable, and the type of drill bit and the drill bit size which is to be used for subsequent operations and processes. Calibration of helicopter subassembly parts in order to reduce the errors in the final part. Instrument handling. An engineer must have brief knowledge on instrument handling. Fifth one is riveting process, types of rivets used for the subsequent process. Basically, rivets are permanent joints, but in some cases, rivets can also act as temporary joints. Heat treatment process, basically manufacturing of helicopter parts, especially in dynamic technologies. Entire process starts from scratch, means from sheet metal to Bell 407 helicopter. In between final and initial, there are lot of processes which is to be carried out. Among those processes, heat treatment process, sheet metal operations, CMM operations, etc. will be coming in the flow. CMM means coordinate measuring machine, means it rectifies and gives the report on whether the drilled holes or rivets are whether done at the proper place or not. The ninth one is reviewing all methods engineering documents. So annually, according to the customer requirements and according to the standard requirements, all amendment histories and methods engineering documents will be revised annually. So there will be major changes in the process and the process flow. So frequently an engineer should be reviewing the documents. This is Plan of work. Tasks performed. The first task which I have performed is preparation of route code or route sheet, which is also called as assembly operation sheets for all parts of Bell 407 helicopter. So for preparing the route sheet or AOS, I have got several inputs from the senior engineer, but even though I have got inputs from the senior engineer, I have to go through amendment histories and related documents to prepare one assembly operation sheet for a small subassembly of Bell 407 helicopter part. The second task performed is calibrated every single part, that is subassembly of the helicopter. After subassembly is ready, once after it's ready for taking for further process, it should be mandatorily calibrated for rectifying and verifying the errors. The third one is classification of the processes based on the process index number. So for each and every processes there are index number. So process index number are as follows. For example, 9010, 9020, 9030, 9040. In Bell standards, 9010 means riveting process, 9020 means drilling process, 9030 means adhesive application or sealant application process, 9040 means painting. So based on the process index number, processes will be classified. The fourth one is helicopter assembly process has been carried out according to the standards which are provided by the Bell Textron company. Bell is a Textron company which manufactures and designs high-end helicopters. It releases some standards which is called as Bell Projection Standards, which is also called as BPS. According to that BPS, helicopter assembly process will be carried out. Prepare the process operation sheet as per the customer requirements. Here customer is Bell Textron company. According to their standards, according to their projection standards, process operation sheet must be prepared and accordingly the process should be carried out. Reviewed all sub-assemblies and main assemblies of the helicopter. So reviewing is all about supervising whether the process has carried out according to the AOS or not. Laymen will be working on the project. So being an engineer, we should review all the process, whether the process is accordingly carried out or the process is matching with the AOS or not. For example, in AOS, it is if it is clearly mentioned that rivets of type B should be used, laymen should use the same type of rivet, and if it is mentioned that drill bit of 5 mm size must be used for a helicopter sub-assembly, that is item 63 turnover bulkhead assembly. We will be discussing about turnover bulkhead assembly later, but for example I am telling about that. A layman should use the same according to the assembly operation sheet, and supervision must be done by an engineer to verify whether the process is going according to the operation sheet, assembly operation sheet. Carried out riveting processes. So there are two types of rivets, solid rivet and blind rivet. Solid rivets are for permanent joint and blind rivets for temporary joint. Operation of CMM, coordinate measuring machine, in which the drilled holes positions will be verified and carried out drilling process in multiple axes. See, only in one axis a layman can perform drilling operation, but CMM machine can carry out drilling process in multiple axes. So methodology. The first one is technical skills which is used to attain assigned tasks. The first one is engineering skills, manufacturing skills, software development and operational skills, project management skills. Non-technical skills used to attain assigned tasks. Communication skills, problem solving skills, teamwork skills, and safety consciousness skills. Engineering skills is in the sense designing and manufacturing. Manufacturing skill in the sense assembly skills. Software development and operational skills. Basically, all aerospace industries will be using a 3D simulation software in order to have a clear cut about the final product of the helicopter or a flight, CAD, CAM, etc. Project management skills on how we are going to take a project and how we are going to complete the assigned project within prescribed time. And non-technical skills, communication skills. Without communications, it would be a big problem to attain assigned tasks. Problem solving skills. Many complex problems will be arising while carrying out the process. One should have that problem solving skills. Teamwork skills. Without teamwork, nothing is possible. Safety consciousness skills. So this is the actual manufacturing sequence of Bell 407 helicopter. First, it all starts from sheet metal. Sheet metal to heat treatment process. Heat treatment to extrusion process. Extrusion to small assemblies. Sub-assemblies to main assemblies. Main assemblies to main component. Here you can see the indicated red indicator means where here we are having some components which I have worked on. Basically in India, Dynamatic Technologies will be working on those components only, and these components will be process will be carried out at Russia. That is, these components processes will be directly carried out by customers, that is Bell Textron company. So this is the actual classification of sub-assemblies. There are some codes for particular sub-assemblies. Means item 44 means roof and beam assembly, means where it acts as roof for helicopter. Item 52 aft fuselage assembly, this is aft fuselage assembly. And item 54 lower fuselage assembly. In lower fuselage assembly, it contains lower shell assembly, lower aft shell assembly. Item 62 console nose assembly, this is console nose assembly. Item 63 turnover bulkhead assembly. After combining and after assembling these parts, item 44, item 52, item 62, item 54 and item 63, DTL, Dynamatic Technologies Limited, will be sending the same assembly to the Bell, that is customers, and further processes will be carried out by the customer according to their own requirements. So Bell 407 helicopter sub-assembly parts with subsequent codes. Means I have already told that there are subsequent codes for sub-assembly parts. Item 44 means roof and beam assembly. See, this is roof and beam assembly. This is a pictorial representation, animated representation of item 44, item 52, item 62, 54 and 63, but actual part looks like this: roof and beam assembly, that is item 44. Item 52 aft fuselage assembly, means backside of the helicopter, looks like this. Item 63 turnover bulkhead assembly, which acts as a compartment between pilot, co-pilot and the passengers. And item 62 console nose assembly. Console nose assembly mainly used for aerodynamics purpose. Let me speak few words about Bell 407. Bell is a Textron company which produces helicopter models. Here we can observe that Bell 407. Why it is mentioned 407 means 4 represents particular helicopter, includes 4 bladed rotor system. 0 means version of material used for blades. 7 means it is a 7-seater helicopter, means it is having the capacity of carrying 7 passengers at a time. That's why it is called as Bell 407. Bell Textron company also manufactures and designs Bell 269 Bell 308, Bell 569, etc. Where first number indicates number of rotor blades used, and the version of engine and the version of material which is used for rotor blade, and the seat capacity of the helicopter. Bell 407 has seating capacity for up to 7 passengers, as I told earlier. Bell 407 has a maximum cruise speed of 133 knots. The speed of aircrafts will be measured in knots, means 1 knot is equal to 1.85 km per hour. Here 133 knots means it's around 245 km per hour, and a range of 324 nautical miles, means approximately 600 km per hour. Bell 407 also has the ability to take off and land in confined areas and to operate in wide range of environmental conditions. Sub-assemblies of Bell 407. It contains item 44, item 52, item 63, item 62, etc. So once after combining all those 6 sub-assemblies, we will be getting the final assembly like this. This is the isometric view of assembly of Bell 407 helicopter, which is carried out at Dynamatic Oldland Aerospace Unit, Bengaluru. And this is left hand side view. You can see a curvature of console nose assembly. Over here a glass will be mounted. Glass costs around lakhs together, means one helicopter glass is equal to BMW car price. And you can see turnover bulkhead assembly over here, roof and beam assembly, aft fuselage assembly, etc. And this is front view. Here you can clearly observe the console nose assembly, turnover bulkhead assembly, and aft fuselage assembly, interior of aft fuselage assembly. And this is back view. It's aft fuselage assembly. And this is the bottom view, where you can see over here this is the lower aft fuselage assembly, console nose assembly, etc. And here this is top view, here where rotor blade systems will be mounted, and this is console nose assembly, lower aft fuselage assembly, turnover bulkhead, aft fuselage assembly, roof and beam assembly. So Bell 407 detail parts means for particular item, means for particular subassembly, how many machine parts, how many sheet metal parts, how many extrusion parts, how many miscellaneous parts will be consumed. Here is a detail. For item number 44, number of machine parts required is 6. For item number 52, number of machine parts required is 14. For item number 54, that is 11. For item number 62, that is 8. For item number 63, that is 12. Number of sheet metal parts required for item 44 is 27. For item 52, that is 233. Item why we should consume more number of sheet metal parts for item 52 means it is a huge assembly, that is a fuselage assembly. For item 54 it is 178. For item 62 97 parts, and for item 63 85 sheet metal parts will be consumed. And number of extrusion parts for item 44, that is 0, nil. For item 52 it is 5. For item 54, that is 4 extrusion parts, and for item 62 there is only 1 extrusion part, and for item 63 it is nil. Number of miscellaneous parts in the sense rivets, joints, etc. For item 44 it is 0. For item 52 5 miscellaneous parts. For item 54, item 62, item 63 it is nil. So overall total number of parts used for item 44 is 33. 257 total number of parts will be used for item 52 in order to carry out the assembly operations. 193 total number of parts for item 54, 106 number of parts for 62, and for item 63 it is 97. This is the detail parts which will be consumed for by the sub assemblies operations. And overall, looking over percentage, number of sheet metal parts used is 90%, and the number of machine parts used is 7%, and number of extrusion parts used is 0, and 2% of number of miscellaneous parts used. Here, number of machine parts 51, overall number of sheet metal parts 620, number of extrusion parts 10, number of miscellaneous parts 5. So overall total number of parts used for carrying out assembly operation is 686. So process flowchart or process overview. How we will be carrying out the assembly process? It all starts from preparing AOS. So for preparing AOS, we should get the legacy input. Legacy input is in the sense whatever senior persons or senior engineers were carrying out, the same should be taken as input and same should be implemented in our AOS sheet. So the received legacy input should undergo input data analysis. So once after undergoing data analysis, we should collect the data from sample parts. So once we get the data from sample parts, it acts as additional input. After getting the data from sample parts, we should carry out reverse engineering techniques, that is laser CMM scanning, if applicable for subsequent operations. Now, after that, preparing discrepancy analysis checklist. For preparing discrepancy analysis checklist, we should contact customer for disposition, whether the process which is being started or which is being carried out is correct or not. In order to know that thing, we should contact the customer, because in between, customer should not interrupt the process. So once after contacting the customer for disposition, there comes one condition: is input clear to continue the work? An engineer will be giving the condition to the customer. If the condition satisfies, means if customer approves the condition, aircraft will be imported, coordinating system, reference planes, master surface from the master geometry. All 3D drawings and reference drawings will be prepared. If not, again we will be contacting the customer, again we will be doing data analysis, collecting data from sample parts, again doing reverse engineering technique, again preparing discrepancy analysis, again coming to the same thing, that is contacting customer for disposition. The process will be carried out if and only if customer approves. After importing the aircraft coordinating system and reference planes, master surface from the master geometry, 3D model will be developed. As it is very difficult to analyze the drawing in 3D draft, the 3D draft will be converted to 2D drawing. Again there comes the condition validation of 3D and 2D model. If yes, the data will be packaged and the same will be delivered to customer. If not, again we will be developing the 3D model, again we will be generating the 2D draft, again we will be sending the same to the condition. If it is correct, then only the data will be packaged, the process will be carried out, and the same will be delivered to the customer. This is the flowchart, actual process flowchart of the assembly operation of the Bell 407 helicopter. So this is about discrepancy sheet. Here part number 407, 030, 502, 123. This part number means sub-assemblies of sub-assemblies. Means in turnover bulkhead assembly, there are 4 parts. One part in the turnover bulk assembly will be having the part number 407, 030, 502, 123. Okay. Revision history means first revision was done by DTL, that is Dynamic Technologies Limited. Person named Sriranga has been revised the history on the date of 8/3/2017, but the same will be sent to customer. But Bell is a customer, that is Textron company. They found some errors in the route sheet and they have revised again after few months on the date of 3/9/2007, so-called person Bala. So when the manufacturer does revision, it should be named as 1, that is, it should give only the number, revision number 1. But when directly the customer is going to revise the history or revise the amendment history, means he should give a letter followed by a number as shown here. For example, the sheet is to be converted in PDF and renamed as SP to TSP, part number and revision number. See, once for revision history, once the customer enters for revising the document, SP should be renamed as TSP. For example, how actually it works means, type, for example, we will consider rivet hole, dimensions of 0.098, sample part 6, drawing 22, loft 22, and MEPI and TDP, that is 6. Other holes not applicable. Here customer has mentioned a comment that is follow TDP, means process sheet, for carrying out subsequent rivet process. If not, again revision will be done. This is about discrepancy sheet 1. The discrepancy sheet 2 contains, for subsequent operation there will be subsequent comments which is provided by the customer. According to that only engineers and laymen should work. For example, sample port number 10.76, 0.13, 0.80. For 0.80, customer has mentioned one comment, that is follow drawings and CGM. And for work number 13, he has mentioned that follow drawings and CGM, maintain on the positive side. Positive side in the sense, let us consider datum line. Below the datum line it is considered as negative side, and above the datum line it is considered as positive side. And for 14th process, he has mentioned that follow drawing and CGM, maintained on the positive side, sample part value measured between 0.28 to 0.31. Means he has given some standards, 0.28 to 0.31. Means, for example, let us consider rivet hole. He has given a range of 0.28 to 0.31. For example, a layman has done mistake, means a rivet hole has exceeded the size up to 0.3 to 0.33, but again customer will, that is Bell, will send the revised history. Again customer asks company to perform the task again. So the range must be in between 0.28 to 0.31. This is how discrepancy checklist works. And this is the process flowchart for developing 3D model. First, collecting the relevant inputs. After collecting the relevant inputs, input data analysis. After doing data analysis, aircraft will be imported, coordinate system will be prepared, reference planes, that is datum line, master surface from the master geometry source. After that 3D model will be developed. Again there comes the condition, validation of 3D model. If the 3D model is correct, there are some 3D model checklists which will be provided from the customer, that is Bell Textron company. According to that we should proceed. Otherwise again we should do input data analysis, again we should import aircraft coordinate system, reference planes, master surface and master geometry source, etc. Again we should develop 3D model, again we should send for validation. So after checking as per the 3D model checklist, 2D derivative drawing or 2D draft must be prepared. Again it should be checked as per 2D drawing checklist. After checking is carried out, 2D derivative drawing will be released. Here comes the 3D model representation. So here datum line occurs here, and datum planes. If an observer sees from here, it is negative side, and if observer observes from here, it is negative side. If observer observes the drawing from here, it is positive side. So these terms are highly confidential, and company won't allow us to know those things because it may cause privacy issues. So here we have limited knowledge upon datum planes and datum lines. Coming to the sample sheet metal parts used for assembly operations and for heat treatment processes also. Here some glimpses of sample sheet metal parts. This subsequent part is used in doors of the helicopter, rods of the helicopter, and footrest. And here in cabins, pilot cabin, this component will be used, and here this component will be used for holding the door, and this component will be used near gearbox and all. And these are also some sample sheet metal parts used. Basically you can observe this component where it is mounted on the roof and beam assembly in order to mount rotor blade system, which acts as a supporting system for rotor blade system. And these are sample machine parts used. There may be of clamps, see here robotic arm, etc. Will be the machine parts which is used for carrying out the assembly operations. At last, conclusion. What I have gained from internship: a knowledge about organization structure of dynamic old and aerospace is gained. A brief understanding on the overall process in which a part undergoes in the company is gained. Different ongoing projects in the company has been observed, like Bell 407, Boeing F-15, Chinook, Boeing P-8, Airbus A330, etc. has been gained. A brief understanding on overall assembly operation, heat treatment processes, CMM operations, extrusion processes, sheet metal operations has been gained. Blank idea and knowledge of how an manufacturing industry works for a project has been gained. These are the references. So feel free to ask questions. Comment your questions in the comment box, so I will try to answer your questions. Thank you.